not going to take a lot of your time, but I think that the conversation that we're about to have is really the basis of why you're all here this evening. I'm just going to ask you to kind of tone down the conversation in the background, and if you really need to talk, to go upstairs so that we give Dr. Kadambi an opportunity to be heard on some critical issues. My name is Selika Josiah Talbott. I am an adjunct professor at USC. I teach the future of transportation and new mobility to urban planning students, particularly in the area of autonomous vehicles and electric vehicles and robot delivery. I spent 18 years practicing as a product liability defense lawyer. Please do not hold that against me. And moved from Washington, D.C. to California 9 months ago. The reason I did is because 1 out of every 5 vehicles in the United States is in the state of California. And if you can impact this market, you impact the nation and the world. I am probably the biggest champion that you'll ever meet when it comes to autonomous vehicles and what it can do for our life, how it can improve people's access and opportunity. Transportation is mobility, and mobility is freedom. It is the connector to jobs, to food, to healthcare, housing, and every single thing we do in our lives. We do know that with the advent of technology and the progress that scientists have made in the fields of autonomy, that it is on the cusp of autonomous vehicles. Dr. Kadambi, who is from UCLA, so this is a preview of the Big Ten. We have USC and UCLA here this evening, is on the very forefront of technology and how it can improve our lives, encompassing all things, not just autonomy, but also healthcare. I want to give you an opportunity to first introduce yourself and tell us a little bit about how you got to where you are.
Sure. So thanks so much for the invitation. So thanks so much for the invitation to be here. And it's a privilege to be here with you, Selika. So my name is Achuta Kadambi. I'm a professor at UCLA in the Electrical Engineering and Computer Science Department. My research kind of deals with building these sensors that can pick up very small invisible signals. Sensors are really important for all types of things in engineering, whether it's robots or medical instruments or virtual reality. And my goal is to make better sensors and kind of invent the future of these devices. Some of the technologies I've worked on have been commercialized into startups. We recently had a company that was acquired by Alphabet. We have another company in mobility and autonomy, so something that definitely ties into Selika's expertise. And we're working a lot with clinicians at UCLA, including some who are here, like Ali Jalalian, to essentially translate some of our inventions to the clinic as well. So that's kind of a brief snapshot about myself. I came to LA, shortly before the pandemic and started at UCLA, and born and raised in California.
Thank you, Dr. Kadambi. I want to first talk about the work that you're doing in machinery. The idea that robotics and technology improves what we see happening perhaps in a warehouse or in a assembly line. Can you tell us a little bit about that work?
Yeah, so one of the technologies we worked on was enabling robots to see. Right now, robots are mostly a mechanical engineering thing where you have like a robot arm and you can position the arm and pick and place objects. One of the hard problems is where does the robot actually go and pick up? So it's kind of giving robots the gift of sight. And I think if you give robots the gift of sight, they can better sort packages, they can make sure that things that are assembled correctly. For example, a lot of car parts are assembled by robots in a factory. And so to make these cars safer, again tying in with transportation, it's important that they're assembled correctly. And so some of the work that we've done has been on teaching robots how to see. And that's kind of one of the main challenges. We also call this computer vision.
From an equity standpoint, because that's the big buzzword that we hear everywhere we go nowadays, I think there's a belief that if we have robots doing certain work where we're replacing people, that the people will lose jobs. And the robot's displacement isn't good for us as a society, and sort of the notion that the robot is more important than the human. What would you say to that?
Well, my first answer is I think that's where engineers need to work with policymakers to make sure that the right things are being invented and mapped to the right, kind of areas of society. I think what I've heard from a lot of policymakers is that where it makes sense to automate is when you have jobs that are dangerous, for example, for humans to do, so the work otherwise cannot be done safely.
I think that makes a lot of sense, and I will tell you as a transportation person, I hear this idea about a robot delivering your pizza or the food or medicine that comes to your front door, and people being concerned that the robot is replacing a job that someone has now. But if you all live in California, that $15 an hour job could not possibly support you and your family. It couldn't pay for rent in California. It certainly wouldn't get you a vehicle, much less have a partner and children that you're supporting. So the idea that a robot could take these jobs and then we could upskill people to things that would allow them to have a quality of life is really exciting from where I sit from that policy standpoint. I also want to talk to you about the notion of bias in AI. Again, this is a topic that I hear from people all over, that there's a concern about the robot and the machinery and the artificial intelligence, and it's a little scary. Before we get to the scary part, though, I'd at least like from a benefit standpoint for you to explain some of the things that AI can do to improve biases that may already exist.
Yeah, I think definitely. So there's a lot of biases that exist in almost any technology. Technologies are not totally inclusive, and the biases can occur in a lot of ways. It could be like how a data set was collected and how machine learning was trained on that data set. It could be problems with the algorithm itself. A good example is like a simple thing that you don't think of is like mean versus median. So mean versus median, if you have that calculation somewhere in your algorithm, it's going to behave very differently, right? The median is not going to account for people at the edge, while the mean may at least take that into consideration. So there are algorithmic differences. I think one of the areas that I think is tremendously important going forward is essentially, on the sensing level. How are sensors themselves biased? And so we have these medical devices that are used in the clinic, like pulse oximeters and other such devices. And on darker skin tones, it's difficult for them to get, measurements that are accurate, and this leads to poorer quality of clinical care for different groups. And so I think that AI can really help actually be used as a tool for good to hopefully remove these biases or resist these biases to kind of a better degree than not using AI.
So one of the examples that you and I talked about is something that was literally a light bulb for me. I don't know how many people here have had the problem, especially people who are darker skinned, of going to a public restroom and putting your hands underneath the soap dispenser or the water dispenser. But not everywhere, but in many instances, there is an engineering component there that has a specific repercussion for people with darker skin. And I'd like you to explain that a little bit.
Yeah, so I think when I was starting at UCLA after I graduated from grad school, I actually went on a trip, and I went on a trip to kind of a Scandinavian country, and I couldn't like trigger the soap dispensers. It was kind of like 2 in the morning, and I had to actually wait for somebody else to come in to trigger that with lighter skin. And so that kind of led me to kind of Google this problem and see if other people had dealt with that. And I saw this video from Nigeria, which I think was really telling, because Nigeria is a country where many people have dark skin. And in one of the restrooms in Nigeria, you see a gentleman trying to trigger the soap dispenser. He tries a few times. One of the tricks that people with dark skin use is we use our palms, because our palms are lighter than the back of our hands. And he's still not able to trigger it. And so you know what he does to actually get the soap out is he actually takes a paper towel, because it's bright white, and puts it on top of his hand, and then puts it under the soap dispenser, and immediately, with 100% accuracy, he demonstrates that this is, dispensing soap. So I think, this is kind of a trivial example in some ways. It's an inconvenient example for us, but many people, people are pretty resilient around the world. But I think where this is an issue is that the same principle that's in these devices is then used in treatment decisions, right, or clinical treatment or clinical measurement. And so that, I think, is an important thing to keep in mind. I think one other point, maybe to segue on this, is that, you don't often realize the problem until you experience it yourself, right? So when I was growing up, I didn't really think this was a big problem because the soap dispensers I was around weren't this bad, or maybe the battery was just dying on some of them. And also when I was a kid, many of the dispensers were manual, right? The automated faucets really started coming into mainstream a couple decades ago. So I think that experiencing it yourself then, is really important for engineers. Engineers are problem solvers, but in some ways the engineers need to experience the problems firsthand.
I think that the idea of the problem solving and the lived experience, or that firsthand, can translate into almost any space or career that we have. Apparently I've had a lot of jobs, so at one point I was a regulator. And I ran the DMV for a state. And in that space, I made decisions about every mode of transportation that a motor vehicle was involved with. So your motorcycles, even your boat licensing, your commercial driver's license, your school buses, all of that. But I left my garage in the suburbs and drove to the city, in my garage in the city, and went upstairs and made policy for people whose lived experiences I couldn't possibly understand. As we think about ourselves and the spaces that we're in, how we go to work every day, who we impact in the work that we're doing, we should be cognizant that not everybody's living exactly like you're living. Not everybody's experiencing life the same exact way that you're experiencing it. So it's important to be as inclusive as possible when we're problem solving, so that we can meet and address as many people's issues as possible. I told you I'm really bullish on new mobility and transportation, but I'm getting up there. I qualify as of December for senior citizen status. So as we look at getting older in America, they say that the average 5-year-old should expect to live to 100 years of age. The 5-year-old today is living to 100. But that would take into account that their health care is as pristine as possible in order to carry them through those years. So when you, in the work that you're doing, in the companies and in your innovation, what are you doing to take into account the concerns of, we have a long way to go. If you're 5 and you're living to 100, what kind of innovation are we looking at and are you working on?
So I think, there's a lot of innovations that we're working on at UCLA, but I think that the lived experience is it's not just like the equity and inclusion buzzword, but I often see it in what makes a successful company. So I think people have to actually experience the challenges that they're trying to solve with quote-unquote AI to be successful. So a good example is farming tech, right? Everybody's applying AI to agriculture right now, building rovers that navigate and so on, but I feel like a lot of the more successful companies have founders who understand the challenges that farmers face, have actually been on a farm themselves, and have done that experience. So it's not always possible to have a lived experience like that, but I think definitely you recognize founders or people who are starting these companies who make that effort to try to get that lived experience, whether it's by talking to policymakers, talking to stakeholders, or actually like just changing their boots and going to the farm, right? So I think whatever innovations that are pursued either by myself or by others, I think that's kind of a really important thing for the next, I guess, century.
If we're sort of wrapping up here, but from an AI standpoint, when we're thinking about artificial intelligence and all the wonderful things that it can do in our life, but as well as some of the drawbacks, questions of trust and privacy, what would you say is the takeaway that you would like the audience to have?
I think the takeaway that I would like the audience to have is when we talk about equity and inclusion, there are actually a lot of exciting, hard technical problems in this space. And so there is somewhat of a perception that, it's purely about the social impact, which it is. But there's also amazing technical challenges there. And so policy, technology, and equity kind of all form this kind of triangle. And a good example is, again, those soap dispensers. It's simply harder to get them to work on darker skin. It's a harder technical problem, which is why it's not solved. So if you're excited by the hard technical problems, then I think you should be paying particular interest in equity and inclusion.
All right, so I started out by sharing that I'm a big autonomous vehicle person. And I caution all of you out there is no such thing as an autonomous vehicle on the roadway that you can personally purchase and drive today. But I also teach about the future of transportation. We almost always teach our classes that the idea of being able to move under certain conditions in geofenced spaces, I've been on lots of autonomous vehicles, is possible today. What do you think about the likelihood that we could get to level 5 autonomy? You're into vision technology, level 5 autonomy, which would mean that a vehicle could go anywhere, any place, under any condition.
Yeah, boy, that's putting it on the spot. Well, first of all, I think I would teach my class the same way. I tell them the same thing, is that we have it working in geofenced environments, but getting it to level 5 is not something that is currently solved. I think that it's actually really a societal question in some ways. I think that the way that companies are approaching it now, just trying to plug images into AI and sensors into AI, I don't think that's going to quite work in the next decade or two. It'll be far out before we get to truly level 5 if we do it this way. I think what's going to have to happen is we're going to have to rethink how cars behave. We're going to need cars to be networked, almost like trains, where you have trains are very safe because they're going on a fixed course. We're going to need cars talking to each other. And in that way, they can do things that humans can't, and that's the way they're going to approach level 5. I think the way Tesla approaches it, in my view, is not the right way currently, which is they use cameras and say, oh, the humans have eyes and they're like cameras, so cars can do that. I think for engineering to reach a level 5, we have to do it differently than humans, much like the jet plane is different from from a bird, right? In its principle. So how long will that take? Well, it's hard to answer that question as an engineer because it's really a societal and policy issue of how people want to approach this. Maybe companies need to band together and share their data and do that. But it's definitely if we put somebody on the moon and had that kind of cohesion to get that happening, I think we can do that with level 5 autonomy if we choose.
Well, as a policy person, I'm happy to work alongside the innovators to see it happen sooner rather than later. Thank you very much, Dr. Donald. We appreciate your time and for having you share some of the work that you're doing with us. And thanks to LAAI for having us. Thanks, Todd.
Thanks a lot.
It's great to be here. Thank you, everybody.
Thank you very much. I appreciate it.
Great,